Welcome everyone. Thank you for being with me. I'm Christophe Nasarre, and I'm here today to talk about monitoring your .NET application. So I will discuss the existing ways to monitor your application, what it means to monitor an application, and why you should take the time to monitor your application. I will show you a better way to monitor your application than the usual one. And then in the second part of the presentation, I will dig into what's new with .NET Core and .NET Core 3.0. I will do a lot of demos, show you a lot of code. All the code that I will be showing you today is available in my GitHub repo. You will get the link at the end of the presentation. And I have a quick question for you. How many of you are developers? Okay, everyone. So I will try to give you the fact and the explanation that you can use with your manager to explain why you should monitor your application and why you should use the ways I will be showing you today. So let's start with the minimum stuff. So let's take an example. When you go to the hospital, or if you take a look at, if you watch series on TV, you will always have this kind of screen with the heartbeat, plus the blood pressure, plus maybe the oxygen and all that. It's the idea of a monitoring system that helps you figure out if your application is behaving well. That's the first level of usage of a monitoring dashboard. The second one is getting alerts, meaning getting notified when something goes wrong with your application. And finally, maybe the most important one, is to help you start an investigation to figure out the reason why there is a problem with your application. So here I've used, so it should be big enough for you, a few, sorry, I just need to change my pointer so you will see it. This is red now. Should be easier. So I have picked a few performance counters. The performance counter on Windows is the usual way to monitor your application. You have a few that are related to a .NET application. I have gathered most of the important one. So the first one I want to take as an example is the number of exceptions thrown per second. What this one gives you is the number of exceptions that happens in your code, but where a catch block gets the exception. Why would it be a problem? It could be a problem if you have a large number of exceptions. Okay, large would mean like tens of thousands, hundreds of thousands, millions of exceptions per minute. We had a talk last year explaining this kind of situation. And it's good to have this kind of monitoring because you can figure out that there is a problem, but you would really need the name of the exception, the type of the exception, plus maybe the message in the exceptions. Otherwise, it's very hard to figure out where the problem could come from. So here you see that the performance counters doesn't give you all the information you would need. The second one is the contention rate. So what is the contention rate? It counts the number of time one thread tries to acquire a resource, but another one already has the resource. Okay, so it counts the number of time one thread will wait to acquire a resource. Is this important? Maybe. Why maybe? Because it really depends for how long your thread will wait for the resource. Because if it's a very, very short time, it might not impact your application. So this is the kind of metric that could be what we call a false positive. You think that something bad is happening, but it doesn't really impact your application. What would be more interesting is the duration of the contention. So again, something is missing from these numbers. The rest is all about a garbage collection and how your application is allocating memory. So for example, we have the number of garbage collection by generation. So you might know that the Gen 2 collection might be more impacting in the performance of your application, but something that you might not know is that this count does not really reflect the reality. if there is a Gen 2 that is happening, then the count for Gen 1 and Gen 0 will also increment. So the number you are looking at is not really the number you think you are looking at. That's another issue with the monitoring system. You need to really trust the number that you are looking at. You also have the finalization survivor. This one counts the number of instances of type that implement a finalizer that were no more referenced by your application, and the garbage collector has to keep them alive in order to call their finalizer. Why would it be a problem? Because maybe if you have a large number of such type, the memory that they are using might increase in your application because the garbage collector can't reclaim the memory because it has to wait for the finalizer to get called. So that's interesting, but how would you figure out which are these types? Maybe these are types from the BCL, from the base class library. So it would be better to know the name of the type of these instances, but you don't have them. So you see that the performance counters are good, but not enough for really monitoring the health of your application. And by the way, if you are going to .NET Core, forget about the performance counters. No more performance counter with .NET Core. Okay, so now you are just like this. You don't know how your application is behaving. It's Windows only, okay? So what should you do? You should use another system which is based on traces that are sent by the CLR, by the Common Language Runtime, by the .NET Runtime, and a lot of traces are emitted by the runtime that gives you the missing information and mention, and also give you more accurate values. And I will show you this in a moment. So the first step is very quickly to explain what is the channel used by these traces to reach your monitoring application. This is based on event tracing for Windows, or ETW. And in this mechanism, it's a kernel-based tracing system, very, very, very performant. So it doesn't impact your application. And when your application is running, it can use some subsystem like the kernel, obviously, some networking stack, and the .NET framework. Each of these modules exposes what is called a provider. And in a provider, you can select the category of event you are interested in. It's called a keyword, and also the verbosity level of the event. And sometimes some of the events might be very expensive to get, and I will give you an example of that. So how do you listen to them? You create an ETW session, and you can either get the event at runtime, or you can ask to generate a file, an ETL file on disk. That's the main principle of this architecture. So why is it interesting for us? It's interesting for us because the .NET runtime exposes one provider with a lot of categories, a lot of keywords that are really interesting. The one about the garbage collection, the one about the exceptions, the one about just-in-time compiler, a lot of information. And all these events are defined in one XML file that contains the format of all these events. So I gave you the example of the event that you will receive when an exception has been caught in your code, in a catch block. And as you can see, you have a bunch of information like the type of the exception, like the message of the exception. This is exactly what we need. So you see that you will get the missing information I was mentioning earlier. The second thing is more related to the fact that maybe you would like to better understand how the CLR, how the common runtime is working. And if you are in this case, you usually ask to clone the repo on your machine, okay, recompile the repo, and try to debug it with WinDBG, or look at the hundreds of thousands lines of code and trying to understand how it's working. There is a good way to more specifically go into the source code for a specific case. If you are interested in exception, I've shown you the name of the event that is generated by the runtime. this CLR ETW all.man file gets compiled when the CLR is built, and it generates a bunch of functions, each one corresponding to the emission of the event. So the prefix of the function are fire, ETW, and the name of the event. So if you search in the source code for all these functions, you will see where in the code of the CLR they are emitted. And it's a very good way to more easily understand how things are working internally. So let's start with a demo about how would you collect these traces, these events. For that, I will be using a tool called Purview. So Purview is a very nice tool from the 90s, as you can tell from the UI. You have a collect menu, and you can either run or collect. What it means? It means that if you run, you will run an application, and you will collect all the traces since the beginning of the application. If you have like a service running, you can't run the application, so you can collect as the application is running. So this is what I will be doing right now, because I have a small application that I'm using, a kind of simulator to generate exception and so on. So here I'm selecting the name of the file that will contain the traces, and I'm just starting the collection. So for example, in my application, I will generate 10 exceptions. That's it, just 10 exceptions. I will stop the collection, and here you can see that it takes some time for Purview to compute all the traces. First, because ETW is a machine-wide system. What I mean is that you will get the traces for all the processes running on this machine. So it could be big. Second, Purview is also listening to other providers, like the kernel provider, to get the snapshot of all the call stacks of all the threads of all the processes. Because you could also use Purview to do a kind of profiling of your application. This is the tool that is used by Microsoft to do most of the profiling. But here you can see that at the top, the .next.etl file has been generated, and I have a list of views that will show me some information. I just want to show the event one. This is the one that will show you the list of all the events that have been collected by Purview. Remember, I just want the traces for my application, if I can type it right. And I'm only interested in the one from .NET. So the name of the provider is the Microsoft-Windows.NET runtime. And in my case, I want to see what's inside the start event from the exception keyword, the category. And you can see that I have 10 lines. Each line shows the event corresponding of the exception. And if you look at the content of these events, you get the name of the exception, the name of the type of the exception, plus the message of the exception. If you want to get more details about the exact payload, then you can click and you will get the exact content of the payload. Why is it interesting? It's interesting because I would not say if, but when you will be using this mechanism, you will do some debugging, write your own tool, and you will need to correlate what's in the XML file I've shown you and the documentation. Most of the events are documented by Microsoft, but sometimes you don't really know the exact value of the field. With this tool, you can just figure out what the values could be. So it's a very handy tool. Okay, so now that we've seen that, it would be great if we could write our own tool. Why? Mostly because in a monitoring system, you want to get the value of the stuff you are monitoring live. You don't want to generate a file, look at a file, and then say, okay, we might have a problem. You want to have, like for the performance counters, like a graph of the evolution of the values. So you can do this thanks to the trace event nugget package. This is provided by Microsoft. It's also an open source project, so you will also get the source code, mostly because Purview is based on trace event. So you will have the same power as Purview has, and you could also take a look at the source code. So if you have some question how to use it, you can take a look at the Purview source code. So basically what you will have a type, an ETW trace event source that will wrap the ETW session. From the session, you will get a source, and the source will get a parser attached to it. Why a parser? Because the parser will extract from the payload of the event all the information for you and give you a nice C# object, an event args, if you prefer, that your event handler will just read and get the information from it. So how would you do that? Sorry, I need to bring my additional eyes. So this is the code that you need to write. Again, all this code is available on my Git repo. You will get the link at the end. And this is fully reusable code, okay? You can take it and just use it. So basically, you create a trace event session to get the event, and then you will ask the session to get the provider you are interested in and the category, the keywords, and the verbosity level. I have wrapped everything in the CLR Events Manager. This class, what it is doing is creating some options. In the options, you can ask for specific processes. Again, remember, ETW sessions are for every process on the machine, but you might be interested only in your application. So you know their process ID, you give them in the option. The second step is to register the listener, meaning you know the event you are interested in. I will give you the details of all the interesting events in the next slides. So you are just registering them. Remember, it's the CLR parser that exposes all the C# events corresponding to the CLR traces, and you just attach your event handler. Once this is done, on the session you say, I'm interested in the .NET runtime provider only. I don't care about the network or all that stuff. And you provide the verbosity level, the keywords. In my case, since it's a generic sample, I'm just almost getting all the events about contention, threading, exception, and so on. And once this is done, you call the process function on the source. And what it means, it says, okay, now everything is set up. Please, if you get some traces, get them and call my event handlers. This is a blocking call, and this is why in my application I had to wrap it into another thread, because otherwise my main thread would be blocked. And that's it. From now, you will get all the traces you are interested in. It's really, really easy. So the next question is, what are the interesting events? So the first one is the one I've used at the beginning of the presentation, the one about the exception. This is the easiest case. Why? Because you get one event to listen to. So if we look at the implementation and we can go to the onException start, which is the message I'm interested in, I will get the exception type and the exception message from the event args received by my event handler. Easy. The second one is a little bit complicated. It means that for the duration of a contention, remember when the threads need to acquire a resource, the CLR does not generate one message for that, saying, oh, this is how many milliseconds you have spent waiting for this resource. So you receive two events. One, when the thread tries to acquire the resource, but there is already someone getting the resource. And the second one, the contention stop, is received when the first thread releases the resource, and you can access to it. So how would you compute the duration? You would compute the duration by using one field which is always common in all event args that you will receive, which is a timestamp. The timestamp is a field that is filled by the CLR when it creates the payload and sends it to ETW. So easy, what you would do, you would remember at what timestamp you received the first event, and when you receive the second event, then you compute the time difference. Okay? So this one, the threadpool starvation one, I've been using it in this presentation for two reasons. First, because it's really interesting case to monitor, which is the threadpool starvation. I don't want to dig into the detail. I've made a presentation with one of my colleagues during Dotnet in St. Petersburg, and you have the recording about why is there any problem with the threadpool starvation. But the interesting fact is that you will receive an event that will tell you, hey, you might have a problem of threadpool starvation in your application. The second reason is because it's very hard for me to say the name of the event. It's the threadpool worker thread adjustment event. So if you receive this one and you read at some of the field, then you will know that you have a threadpool starvation issue. There is no performance counter that would give you this information. For the finalizer, you remember this is the case where you want to know the name of the type of an instance that gets finalized. So how would you get it? You could imagine that, like the exception, you will get a message that is the GC finalize object message, and in the message you will get the name of the type. This is not the case. Why? Because there might be a performance problem. What I mean is, if you have hundreds, thousands of such objects, the payload might contain the full name of the type with the namespace, and it's an inter-process communication mechanism to send the string from one process to all the listening process. So what they decided to do is sending one message with the name of the type plus an ID, which is the type bulk type event. And when you will receive the GC finalize objects, you will receive only the ID. So you will have to create a kind of dictionary to know the name. I mentioned that some of these events might be expensive. This one is a good example. It's the GC allocation tick event. This event is sent by the garbage collector. Each time it allocates 100K of memory. And what it sends the name of the type that was allocated last. Then allocate up to 100K. Again, send a message with the name of the type that was lastly allocated. Imagine that your application is allocating gigabytes of memory per minute, for example. You can imagine the number, tens of thousands, hundreds of thousands of such messages. And the cost for the CLR to compute the name of the type could also be expensive. So this one is very expensive. So to monitor the health of your application, you won't need this message. However, if you think about it, this is a kind of simple memory profiling, like a sampling profiling of your memory allocation. So if you detect that you might have a problem in your allocation pattern, then this message could be very interesting because it's a cheap way to get the sampling of the allocation in your application. There are another information that you don't have with the performance counter, which is really, really important, especially for server application. This is the suspension and the pause time. What is this? During a garbage collection, you have different phases. And in some of these phases, the GC needs to stop, to suspend your threads, meaning that all your code, all your threads will be frozen. They won't run up to the time that the GC finishes to do its work. And this could be a real problem. So it's not really the number of garbage collection that happens in your application. It's the duration of the pause time during which your application does nothing. That's the important part. So to compute that, you have to listen to two events. exactly the same as we've done for the contention. You know the timestamp of the first one, the timestamp of the last one, and you just measure the difference. I have one full blog post dedicated to the garbage collector. It's a very complicated story, but you have all the gory detail, especially the one to compute all the rest of the information with a bunch of messages. But you can get this information. I've done it for you. You just have to reuse the class and you get all the numbers. Okay, so now it's time to go to .NET Core. Everything I've told you from the beginning of the talk applies to .NET Core. So all the traces and all the code I've shown you, except the beginning of the ETW session stuff, will apply. You won't change any line of code. So what is the change? The change is that Microsoft realized that they needed to provide one unified way to send traces from the CLR to monitoring application. Today, with .NET Framework and .NET Core, you add the ETW on Windows and LTTNG on Linux. So you have different mechanisms to get the traces. Here, they create a new one called EventPipe. EventPipe is a pipe through which you will get some event from the CLR. How is it working? It's working that way. When the CLR starts, there is a C++ class called diagnostic server that spawns a thread. This thread will listen to messages, commands sent by monitoring application through an event pipe. What is an event pipe? We have two implementations, one for Linux, one for Windows. So the one for Windows is using NET-Pipe, which is an inter-process communication mechanism, and on Linux it uses domain socket. And that's how we will have one unified API to get the traces both for Windows and Linux. So I want to show you one implementation detail that explains how the tools are working later on. I mentioned that they are using name pipes. There is one tool, not from sysinternal this time. It's called Windows Object Explorer. And I thank Pavel for giving me the name of this tool. If you click on the extra menu and you click on pipes, you get the list of all the name pipe. So as you can understand with name pipe, each pipe has a name. So if I'm looking for .NET, you see that I can have a .NET-diagnostics-14228. And guess what? This 14228 is the process ID of the application. That's how the tooling provided by Microsoft will know which process contains a .NET Core runtime. So let's see what you can do with this. Microsoft provides free tools today that are using this new mechanism: .NET Trace, .NET Counter, and .NET Dump. So all these tools, you can install them very easily if on your machine you have already installed the .NET Free SDK. So this is good. You just type .NET Tool Update and the name of the tool, -J, a G, for global, and it will install the tool. This is good for your developer machine. But imagine, would you go to your IT and say, okay, guys, you need to install the .NET Core Free OSDK on all our servers, or in all our containers, or we have customers, we want to investigate some issue, we will ask them to install the SDK on their machine. You won't be able to do that. So instead, you just get the repo, which is the .NET Diagnostic repo, you compile it, and you get the binaries. And you just copy the binaries on the box, on the machine. Very, very easy. So let's see what you can do with these tools. So again, the first thing you can do is type the name of the tool. So .NET Trace. What is .NET Trace? .NET Trace is the tool that you will use to collect the traces. Remember, I've used Purview to collect the traces. Now you will use .NET Trace. And what are the commands? You will have the collect command, I will show you in a moment, and also the list processes. So the list processes, is the one that is using the mechanism I told you. Look at the name pipes, look at the process ID. When it gets the process ID, it is able to get the name of the application. But look, we have another application, which is .NET. So let's start again. And you will see that the process ID is not the same. Is there any ghost on my machine? No. It's just the fact that the tool is counting itself as a .NET Core application. So if you want to use this tool to write some script and know which process you can monitor, you have to be very careful about this one because you don't want to monitor this one. Okay, so you get the list. We also can collect, so let's do a collection. So .NET trace collect -p 14228, and it will start collecting some information. So again, I will do some exceptions. So this time I will generate 5 exceptions, and I will start to do some allocations. If you look at what is displayed by the provider, by the .NET Trace tool, you see that you have 2 providers. One is the expected Microsoft Windows .NET runtime, the one that I've discussed since the beginning of this presentation. And there is another one, which is the sample profiler. This one is created, and it's new to .NET Core. And what it does, every millisecond, it suspends all the threads in the application, like a GC would do, take a snapshot of all the call stack, and resume all the threads. So you can imagine the impact on your application. So it's really a profiler, but a sampling profiler. Every millisecond, you will get the information of all the call stack. You see also the keywords corresponding of which category of events you are interested in, plus the verbosity level. So it means that I would highly recommend that when you are taking a trace just for the messages, you don't use the default value because it has a real impact on your application. But when you want to do some profiling, then you can use it. So let's stop the collection, stop the allocation, stop the collation. And so now you have a file. You have a net trace file. What would you do with a net trace file? Well, you can see it with Purview. So if I'm going back to Purview and I'm refreshing here, I should see my trace.net trace file. If I'm clicking on the events, again, I will have the same nice window, but this time, remember, we don't need to filter by process because we just have one process. We gave the process ID. So we just have the message for this process. And we are interested in the .NET exception start. And this time I have 5 lines, 1 per each exception. And for each line, I get the name of the type and so on. Just to make you understand that the only change is the way we get the traces. But the traces are the same. Okay, we don't lose anything. The second thing I would like to show you is the fact that Purview is really interesting tool. I recommend that you look at the videos that explain how to use the tool. And one of the interesting view is the GCStat view. The GCStat view gives you statistics about the garbage collector. Here you see we had 14 Gen 0 collections, 0 Gen 1, 0 Gen 2. And here you can have the list of all the collection with some information, what are the reasons why it was triggered, and so on. And you see that we have some different colors for the collection. That way, if you have many lines, hundreds of collection, you can very easily spot which one are the Gen 2. Why am I telling you this? It's because I want to repeat that Purview is an open source project. So if you have some stuff that is missing from Purview, then you can create a pull request. And Microsoft might accept the pull request, and everyone in the community will get the new feature. So the blue stuff is my feature for the community. Okay? So it's true, you can make your own change. It's very easy one. It's just changing the background in the HTML that gets generated. And Microsoft is really interested in getting new feature. So think about the rest of the community. Thank you for that. OK, now, this is .NET Trace. I want to show you something. So the net trace could be used also in Visual Studio. Why? Because if you've used the profiler, I'm looking for my, here, I have created a net trace file here, and I'm dragging and dropping in Visual Studio. And guess what? If it's working, Visual Studio will understand that trace file as a profiler session. Wow, this is really, really good. Okay, so I told you, beware, don't use the sampler provider because it's expensive, but when you need to profile, even on Linux, this is really, really worth it. Okay, so that's the Visual Studio profiler. You also are able to generate another format, which is a JSON file, to use another kind of representation, but I won't dig into the detail here. The last one is Dotnet Dump. I won't do any demo about Dotnet Dump, but basically what Microsoft did is that they realized that when the developers went from Windows to Linux, and they need to do some analysis of the memory of a process, what you would do in Windows is taking a memory snapshot, get a memory dump. We are using proc dump in Criteo, and then you use WinDBG to analyze the memory dump with SOS command. It's complicated, but you can do this. But when you go to Linux, okay, you don't have proc dump anymore. So you have to use another tool, which is create dump, and you have to use another debugger, which is LLDB or GDB. So it's another experience. So Microsoft decided to provide us with one single tool to create the memory dump. It's .NET Dump, and to analyze the memory dump. There is a session this afternoon that will detail how to use the tool, but it's a very, very interesting. Why did I add it into my list? It's because .NET Dump is using the EventPipe to send the command to the CLR to take the memory dump, for example. So it's used internally by lots of diagnostic tools. Okay, so that's about the tooling. Now, what if you want to write your own tool in C#? Guess what? Trace Event has been extended to support the new format and the new pipeline. So you just have to change the tiny piece of code that was the glue at the beginning of the code to bind to the session. It works both on Windows and Linux, and it also supports another scenario. What I mean by another scenario, from the beginning of this presentation, I talk about an application, and you get another application to monitor this application. But sometimes it could be easier for deployment, for example, to have in your server application the monitoring system that will listen to its own CLR event internally to the application, and maybe expose an HTTP endpoint to get the metrics. So that way, you don't deploy any companion application that could make the deployment a little bit more complicated. So the two are possible. Let's take a look at what you need to do for that. Remember, I mentioned this code for the ETW when you create the session. Since we don't have a session, the code is much, much easier. We don't need to create a session. We just go directly to the CLR Event Manager. And this time, what it will have to do, it will give in the configuration the list of the provider you want. So the provider, remember, the provider are the runtime of the sample provider. And then the tiny change is the one that I've shown in the slide. You just change the way you bind to the EventPipe, but you still get a source. It's not an ETW source, it's an EventPipe event source. And the same code from that point will be executed, the one that registers your event handler. So, from there, the same code. The second way to get in-process event is the following. You have to implement a class that derives from event listener. So this example is a class that will save all the data for each garbage collector into a file. It's called a GC log. The people that are working in the Java world know that they can have this for free. We don't have in the .NET world. So I have implemented this one, and as a sample, you can see that we have to override two methods. The first one is called onEventSourceCreated. This override will be called for each provider that is running inside your application. So the sampler provider or the .NET provider. So I'm interested only in the .NET provider, so I'm checking for the name, and if it's the one from .NET, then I'm calling enabling events. This function is exposed by the base class, and what it takes as parameter, it takes the event source itself, and which verbosity level you want, and which keyword you want. Very close to what we've done before. The main difference with the trace event way of getting the information is here there is no trace event. It means that you will have in the second override, in the on-event returned override, to extract the information from the payload yourself. And this is a little bit more complicated. What I mean by a little bit more complicated, I mean you won't get an event args with the value of the field of the payload as a property. You will have to use a helper function to extract. So if we go to the onGCStart, which is the code that extracts the information when a GC starts, you see that I have to know the name of the field of the payload. Remember the XML file at the very beginning that contains all the fields plus the documentation. And based on that, you call the getFieldValue. This function, what it does, it uses the dictionary. The payload is given to you in this event return event args, and my tiny helper function will extract the value from the dictionary. So you need to know the name of the field. Here you need to know that depth means generation, but if you read the documentation, you will get the information. So the two scenarios are possible. Good. So where are we now? The next step is we get the traces. I forget to show you one tool. Silly me. So I showed you the .NET trace, but I didn't show you the .NET counter with an S. So this tool is a kind of performance monitor console-based application for .NET Core. So don't be confused here. I'm using the word counter, but don't think it's the same as the Windows performance counter. This is a new mechanism exposed by the core CLR, and it exposes a list of counters. So if we go to the list of counters, and we zoom in, you see that you have two providers. One for the runtime, which is very close to the performance counters I've shown you for Windows, and one for ASP.NET Core. So you get the total number of requests, the rate of the processing of the request, and so on. So if you run this tool, and you monitor -B 14228, I will keep my stuff here. So you will see that you will have the list of all the counters plus their value. So if I'm starting allocation, then you will see the number changing. Okay, so my allocation rate is almost 2 megabytes per second. And if I get some GC, I should see this number change from 0 to 1. You see? So you get the value of the counters. This is working both on Windows and Linux, all the tools. important. So what if, so I need to exit from this. Okay, and let's stop my allocations. So how this counter mechanism is working. Like with the traces, when the runtime starts, there is a class called runtime event source that gets created. This is a C++ class. And this event source has a role which is bind to the EventPipe. So you get the EventPipe, and then I'm binding to this, and I'm able to send information to the pipe. Next, it will create counters, one after one, passing the name of the counter plus a reference to the source. That way, when the counters need to send the value of the metric of the counter, like the number of requests per second, it will use the event source and use the write to send the payload. The thing in the middle of the two is called the counter group. There is one counter group created by the CLR, and each and every counter automatically adds itself to the counter group. Also, the counter group keeps a list of all the counters, and in addition, it creates a timer, like once every second. And so once every second, the counter group will get to the list of all the counters and ask each counter to please write your payload to your event source. And that way, the CLR will send the information related to each and every counter to the monitoring application. That's how it's working. So now, there are two kinds of counters today. The CLR provides two kinds of counters. Let's say I want to get the number of requests. It's just a number. Per second, you will get the number of requests. You don't need to compute anything. So this one is called an incremental event counter. Now, let's say you want to get the duration of the processing of a request. And if you process 200 requests in a second, what number will you get? You would be interested in getting the minimum duration, the maximum duration, and maybe the average between the two. So this is what the event counter type provides. It gives the min, the max, and the average. Now, there are two ways to get the value you want to take into account. The first one is that you will directly give the duration to the counter. That's one way. So you use the event counter. If you want to compute yourself some value, you can provide a callback to the counter. That's why you have the polling counter and the incrementing polling counters. Why do I spend some time detailing you this type? It's because you will be able to provide your own counters. And that's very, very interesting. So, what if you wanted to listen to the counters from ASP.NET Core, for .NET Core, for your own counters? Again, you can do this in C#. In this table, I have listed all the counters exposed by the .NET runtime with the corresponding API. So that way you understand exactly what are the numbers you are looking at. And I also added the type. So the min is the one that contains the free value. And if you remember, in the demo of the tool, you just get one value. But if you write your own tool, you will be able to get the free values. And the sum is the one with the incremented value. So let's look at the source code. Here, what you have to do is to, again, create a configuration with the name of the provider you are interested in. So, don't be confused. I'm using the word provider both for the traces and for the counters. Why? Because both are using the same EventPipe. the same event source at the CLR level. So it means that the name, did I still have this one? So this is the name of the provider for the runtime counters, and this is the name of the provider for the ASP.NET Core counters. And if you create your own counter, you will have to give a name like the provider name. Once this is done, the rest of the code is almost the same as with the previous trace kind of listener. The difference is we won't be able to use trace event. Why? Because in the traces scenario that I mentioned, each and every message has a different name. This name is passed by trace event, and it knows which field to extract. Here, all the counters event share the same name. So I need to have a kind of generic listener. And the generic listener is the one that exposed by dynamic. So my event handler will receive all the events. But I know that internally, the counter events are named event counters. So now I need to extract myself from the payload the information. The generic way to get information in a payload is that you get a dictionary. Okay, this is a dictionary of string and object. For the counter object, I know that one of these fields in the payload of the object is another dictionary, which is the key value pair dictionary. And in this counter fields, I know that there is one which is called name, and give me the internal name. If I'm going here, this is the name, the internal name. And I also get the display name, which is this one. And then I have the type. Remember, we have two types, the one that brings only one value and the one that brings three values, the min, the max, and the average. So I know that if the counter type is sum, it's just one, and if it's min, it will contain the value of the three fields. And you have the code that extracts the value of the field. So this has been written once by me, but you can just reuse it now. You don't have to bother with this implementation detail. So it's quite easy. The next step is, okay, I would like to expose my own counters, because I think it's something that could be useful, and I will give you an example. At Criteo, we moved from Windows to Linux, and we tested all the preview of .NET Core 3. And during that time, we had some differences in the performance of the processing of the request. And so we were wondering, well, maybe the garbage collector could have an impact on the time we spend to process a request. Remember, during a garbage collector, there are some phases during which your threads are frozen. So the time spent to process a request can be artificially extended. So we needed to figure out the metrics corresponding of the duration of processing a request with a garbage collector and without a garbage collector happening during the processing. So how would you do that in ASP.NET Core? This is the demo I have for you right now. How would you do that? You would create a middleware. A middleware is a type that ASP.NET Core will create and will insert in its pipeline of processing a request. So your invoke async function will be called each time ASP.NET Core received a request. So what would you do? You would count the number of collection that has been done by the garbage collector. And the API to do this is very simple. It's the gc.collection count. So I'm counting the Gen 0, Gen 1, Gen 2 collection. Let's say I have 12 collections before processing my request. Then I'm computing the time that I'm spending to process the request. And when it's done, I'm counting again the number of collection. Okay, so let's say I had 12 before, and now I have 13, 14, 15. It means that during the processing of my request, there was a garbage collector that happened. And if it's not the case, if I have 12, I know there was no garbage collection. So in that case, I have two different sets of counters. I have the counters corresponding to the duration, to the count, for the one with a garbage collection, and the same, but without garbage collection. Okay? That's how you would get the numbers. So now, how would you expose these metrics, these numbers, as counters? You will have to do exactly what the core CLR is doing. You create a type that derives from event source. You give the name to it. It's the provider name. So if you want to listen to your own counters, that would be the syntax. You give the name of your event source as a provider. Next, you create the counters. So I have two sets of counters, remember? The one for the request with a GC and the one without a GC. And you find the same type that I mentioned earlier, the polling counter. A polling counter is a counter that gets the value through a callback. So I'm providing the callback. And what the callback is doing, it's getting the value of one of my fields. And guess what? This field is changed here. So you have the number of no GC request count. I'm counting the request without a GC and the one with the GC. For the other counters that I need to set the value for the duration, I'm just calling write metric on the counter, passing the duration. And this type will do in a thread-safe way. And if you're interested, take a look at the source code to see how they are trying to optimize the computation in a thread-safe way to compute the mean, the max, and the average. And that's it. It's just working. Okay? So, where are we? I've shown you that performance counters are good, but it doesn't work with .NET Core. It does not provide all the information that you need with the accuracy and the missing information. I've shown you that you should use the CLR traces, and I have to tell you that at Criteo, we had a monitoring system based on the performance counters, and now our monitoring system is based on this. True story, okay? I'm talking about tens of thousands of servers. And there is no impact on the performance of your application. You get the link to the trace event, the link to the core CLR, to Purview, to my repo. So all the source code is available there. You have also the blog post corresponding to in more detail about what I've been discussing today. If you want to reach me, you can also use my Twitter account. And as you can tell, I like cats. And I also like rubber duck. And if you find a tiny white rubber duck that looks like a stormtrooper, you know, I would be very kind to adopt it. So thank you very much for your time. I don't know how many minutes do we have for questions?
Yes, 1, 2 questions.
Okay, and then after that, I will follow everyone to the discussion zone. Do you have any questions?
Vance?
Do you have any questions about what you will tell to your manager, why you should do this? I have a question over there.
Sorry. Thank you for great presentation. It was interesting. I would like to know, are we able to collect .NET Dump from Kubernetes node, not from pod directly?
To connect?
To use .NET Dump to create a .NET Dump from nodes, not from pods. If you use Kubernetes.
I'm not using Kubernetes, so I have no idea. I have no idea. But basically what this one is doing is that it connects to the .NET Core application. So if in Kubernetes you can copy the .NET Dump tool, then you can just give the process ID. So it's not working remotely. You have to be in the same container or on the same machine, both Windows and Linux, and then you get the memory dump.
Okay, thank you. We will try.
Yeah, thank you.
And the last?
Thank you for your speech.
Thank you.
Is it accurate to use time span for getting the duration of the event?
Is it?
Is it accurate to use a time span for getting event duration?
A time span, you mean? Or timestamp?
Yep.
Okay, so each and every message you get, so all the traces get the timestamp corresponding to the time when the CLR created the event that you receive. So even if there is a delay in the time between when it's emitted and when you receive it, because the CLR is doing some buffering. So it waits until it gets enough message before sending them. So you might have a tiny difference. But the timestamp you get is the real time when the event was emitted. So even if there is a delay and you receive the event and you compute a difference between two timestamps, it will be the true time that happens in the CLR. So yes, it's accurate to use the timestamp to measure duration. Thank you for your question.